Bismillahirrahmanirrahim. Today, inshallah, we'll talk about the unit circle. The unit circle is a circle whose radius is 1, and hence that's why it's called the unit circle, 1 unit. So, if you superimpose this circle in the Cartesian plane with the center at the origin, this is how it would look. The radius of the unit circle, again, is 1, so each of these radii would be of 1 unit length. And then we quickly appreciate that the four corners, so to speak, of the unit circle, where the circle intersects the x and y axes, would be like this. The ordered pair would be x is 1 and 0 over here, and here it would be x is 0, y is 1, and at this it would be x is negative 1, y is 0, and here would be x is 0, negative, y would be negative 1. So those are the four important intersection points of the unit circle with the axes. Now, the unit circle is very helpful because it helps us establish the basics of trigonometric science. It takes the sine, cosine, tangent, those trigonometric ratios, and combines them with the Cartesian plane and marries them, so to speak, with the algebraic sciences. So the unit circle is very important for establishing some trigonometric principles. Now, a circle, as you know, has 360 degrees. Like this, from here to here, that would be 360 degrees, correct? So, this angle would be 0, and if you go all the way around, this angle would be 360 degrees, like this. In understanding a unit circle, however, it's very helpful to really master the first quadrant. So this would be the first quadrant, second quadrant, third quadrant, and the fourth quadrant. So if you really appreciate what's going on with the unit circle in the first quadrant, which is over here, and then you can extrapolate that knowledge to the rest of the unit circle. So you can focus on the first quadrant, okay? Now, in terms of the angles that are in the unit circle, of course, the circle, is, as we just said, has 360 degrees. So of these that are in the first quadrant, there are three angles that are of particular importance to us. And the first angle from here to here, for example, is 30 degrees, okay? And then the second angle of particular importance to us is this one here, which is half of the first quadrant, which is 45 degrees. And the third angle that's of particular importance to us is this angle right here, and that is 60 degrees. So these three angles that I have drawn over here, this being the 30 degrees, and this being the 45 degrees, and this being the 60 degrees, these are very important to us, and they will help us establish some, as I said, some basic trigonometric principles, okay? Now, from these 30 degrees, 45 degrees, 60 degrees, now you can imagine other angles that are going to be reflections, so to speak, across the x and y axis. For example, this 30 degrees will correspond, this angle, for example, will correspond to this angle over here. Okay, so since this is 180 degrees, right, so this would be 180 degrees minus 30 degrees, and that is going to be 150 degrees over here. Okay, and this angle over here, which is the reflection, so to speak, a 60 degree angle, would be 180 degrees minus the 60 degrees, or 120 degrees. Another way of thinking that would be 90 degrees plus the 30 degrees. In the same way, this 45 degree angle is the reflection over here, okay, and that's going to be 135 degrees, or 90 degrees plus 45, or you can think about it 180 degrees minus 45, regardless. So those two angles are complementary, so to speak, they're reflections, I should say, in that way. And in the like manner, you can fill out the rest of these. So this angle, for example, would be 180 degrees plus 30 degrees. So that's 210. And this angle here would be 180 degrees plus 45 degrees, 225. And this would be 180 degrees plus 60 degrees, be 240. And then this angle would be 270 degrees. And from here you have 30 degrees, 300, and then 45 degrees, 325. And this is 360, and if you take this, it would be 330 degrees. Now this angle, therefore, you can think of it as being reflected, like over here to this angle, and this angle over here you can think about being reflected over here to this angle, and the 60-degree angle over here is being reflected across to this angle. They're kind of like mirror angles, so to speak, right? So now, as I suggested, you can extrapolate all of that from what you know from the first quadrant. So if you know all of the first quadrant, then you recognize that this angle corresponds to this angle here, right? And this angle will correspond to this angle here. So if you focus on the first quadrant and you know the principles of extrapolating that knowledge into the rest of the four quadrants, that's really the foundation of our knowledge, inshallah. But what I have drawn over here, this is basics, and this you must know this. This is the unit circle whose radius is 1. This is 360 degrees in the beginning over here, and this is 30 degrees, 45 degrees, 60 degrees, and this is of course 90 degrees over here. Okay, so that we have to understand. And of course this is 180 degrees and 270 degrees, and the 4 points of intersection of the unit circle with the axes, the ordered pairs that are corresponding those, also we must appreciate. Now, the beauty of the unit circle is, of course, of the knowledge it helps generate. Now, the first thing to appreciate is that since this unit circle is on a Cartesian plane, every point here has a corresponding ordered pair, x and y. Okay, and this ordered pair, the x value here, corresponds to, of course, the x value in the on the x-axis. Okay, in other words, right, this distance from origin to that's the x value, so that's x over here. Okay, and this distance from here to here, if I could kind of approximately do it like this, that would be corresponding y value, correct? So if I draw this triangle over here, and the perpendicular line like this, okay, then you appreciate that the x value, the x coordinate, would be this side of the triangle, okay, like over here, that side of the triangle, and the y value would be this side of the triangle, okay? So that's the first thing you have to understand, okay? Now, so every ordered pair corresponds to a side length of a triangle. Okay, think about that for a second. Okay, every ordered pair here corresponds to a side length of a triangle. Okay, for that 45-degree triangle, for example, this is the x value and that's the y value. Correct? So every ordered pair will correspond to some side lengths of a triangle. Now, if I were to draw this triangle over here, okay, if I were to draw this out over here, that would be a 30, 60, 90 triangle, right? Because that's a 30-degree angle, so this angle would be 30 degrees, and this angle would be 60 degrees, and this angle would be 90 degrees, correct? And the hypotenuse would be 1, correct? And we understand from our geometry knowledge, if you have a 30, 60, 90 triangle, the side across from 30 degrees, is half the hypotenuse, okay? And this side, the side adjacent to 30 degrees, is that side times the square root of 3. So the side across from 30 degrees is half the hypotenuse, and this side is going to be that side times the square root of 3. Now, in our particular example, with the unit circle, the hypotenuse is 1. So the side across from 30 degrees would be half of the hypotenuse, or it would be 1/2. And this side would be 1/2 times the square root of 3, or square root of 3 over 2. Correct? So that we understand, because this is a particular special circumstance. Number one, that this is a unit circle, therefore the hypotenuse is 1 unit long. And then we have a 30, 60, 90 triangle, and the side lengths would be correspondingly as I have described over here. Okay? Now, The x value therefore here is square root of 3 over 2, okay? And the y value over here is 1/2, okay? We appreciate that because that's a 30, 60, 90 triangle. Now we extrapolate this to our knowledge of trigonometric ratios. And if you recall, so, ka, toa, okay? And in this case, if it's 30 degrees, if you were to figure out, okay, let's see, what is the cosine? Let me give myself some room. Okay, so let's write those ratios for 30 degrees. What is cosine of 30 degrees in this case, in this particular angle right here? So cosine here would be adjacent over the hypotenuse. In this case, it would be square root of 3 over 2. The hypotenuse is 1, right? So this is square root of 3 over 2. Now then we appreciate that cosine of 30 degrees is square root of 3 over 2, which is the same as x. So x value, therefore, is actually, this distance here represents the cosine of 30 degrees. So that's cosine of 30 degrees. In the same way, if you do sine of 30 degrees, sine is, opposite of hypotenuse. Opposite is 1/2, hypotenuse is 1, and that is 1/2. See, this occurs because you're dividing by 1, and this is because of a unit circle. And it's very convenient that it's a unit circle because the side lengths become the cosine and sine. So the sine of 30 degrees is 1/2, which corresponds to the y value. So the y value becomes the sine of 30 degrees. Okay? So now this is quite intriguing if you think about this for a second, okay? Now this is one time where we're relating angle to side length. In fact, you're relating the angle to side length. So the cosine of this angle becomes this side length, and the sine of this angle becomes that side length. So in each ordered pair, you'll see this ordered pair, x and y, is in fact sine and cosine. So the x-coordinate is the cosine of 30 degrees, and the y-coordinate is sine of 30 degrees. Now let's do the same thing for the other triangle. Now what I've done here is I have drawn a perpendicular line from 45 degrees to here. And now we have a 45, 45, 90 triangle, right? So we have 45 degrees because this side is 45. Okay, so we have a 45, 45, 90 triangle, so which I've drawn over here. So this triangle over here, which you see, I have drawn over here. Okay, now from 45, 45 degree triangle, if you remember from geometry, okay, I've drawn a little baby 45, 45, 90 triangle for you over here. This is x and x and x square root of 2. So if you knew the hypotenuse, and if you want to get to this side, you would have to divide by square root of 2. Right? So if you want to get from this side to this side, you have to multiply by square root of 2, and to get from this side to the hypotenuse to the leg, you have to divide by square root of 2. So to get this side, right, we have to take 1, and you'd have to divide it by square root of 2. And then to make this mustahab, to rationalize the denominator, you don't want radicals in the denominator, right? So you have to multiply top and by square root of 2. Then you get square root of 2 over square root of 2 times square root of 2 is 2. So that side becomes square root of 2 over 2. And this side is being congruent. This is a 45, 45, 90 triangle, base angle theorem. So this becomes square root of 2 over 2 as well. So this side, this 45, 45, 90 triangle, okay, if I were to go like this over here, a little ziggity-zaggity line over here, and a ziggity-zaggity line here, those are the two sides of the 45, 45, 90 triangle. They're both same length, so the ordered pair corresponding then would be square root of 2 over 2 and square root of 2 over 2 like this. And in the same way, if I could suggest to you over here, and in the same way, okay, this side is the x value, and this side is the y value. In this case, they're congruent, right? Because it's isosceles triangle. The x value, and that's the y value. That's square root of 2 over 2. Okay? Now, if we do the same thing over here, and that is, okay, we say, what is the cosine of 45 degrees? Okay? Cosine is SOHCAHTOA, adjacent, which is square root of 2 over 2, or hypotenuse, which is 1, which is square root of 2 over 2. In the same way, if we do sine of 45 degrees, that is square root of 2 over 2 over 1, or square root of 2 over 2. So this ordered pair, therefore, corresponds to cosine of 45 degrees, and this is sine of 45 degrees. Okay? Now finally, if we do the same thing, let's say, with the 60-degree triangle, okay? So if I were to draw this line over here and create a right triangle over here, now this is the 30-degree side and this is 1. And so this side over here, okay, if I could draw it like this, so this side over here, the x value, would be half the hypotenuse, and that would be 1/2. That's the x value. And the y value would be, from 30, 60, 90 triangle, would be square root of 3 over 2. That's the ordered pair that corresponds to 30, 60, 90 triangle. Okay? Now I'm going to clean this up a little bit. Then you observe the following. Okay? So the x value, the side length of this triangle for this 30, 60, 90 triangle over here, for a second, focus on that, is going to be cosine of 30 degrees, and the y value will be sine of 30 degrees, and we have generated this ordered pair, square root of 3 over 2 and 1/2. So each ordered pair would correspond to cosine of this particular angle, okay, and the sine of that particular angle. So this ordered pair, for example, over here would be the cosine and sine of this angle over here. Okay, and the ordered pair corresponding to this angle would be cosine of that particular angle and the sine of that particular angle, whatever that angle is. Okay, so that is the beauty of the unit circle. The unit circle is a collection of all points whose ordered pair actually correspond to the cosine and sine of the angles thus generated. Okay, so now, as we have suggested, the key is to understand the unit circle in the first quadrant, because from there you can extrapolate all of the rest of the ordered pair. Let's start with 30, 69, the 30-degree triangle. So this angle, okay, corresponds to this angle over here. So this ordered pair would be the same ordered pair reflected across the y-axis. So the x value would be negative square root of 3 over 2, and the y value would be 1/2. Okay, and then this ordered pair over here that corresponds to the 45-degree triangle would be negative x, right? Negative square root of 2 over 2 and square root of 2 over 2, like this. Okay, and this ordered pair over here will correspond to the 60-degree triangle. X value would be negative 1/2, and the y value would be square root of 3 over 2. And from there you can also extrapolate, okay, for this is going to be a 30, 60, 90 triangle right over here. So this ordered pair, okay, will be, now the 30, 60, 90 triangle, you kind of have to memorize it. The longer side is this, because I remember that because 3 is like the biggest number, like square root of 3. And the shorter side is 1/2. So this triangle here, in my mind's eye, okay, it's a 30, 60, 90, and this is the longer side over here. So that's going to be the square root side of 3. So it's going to be negative square root of 3 over 2. And the shorter side is this. And the 45, 45, 90 triangle is reasonably easy over here. So that's going to be negative square root of 2 over 2. Mind you, this is, both of them are negative here. Negative square root of 2 over 2, both x and y coordinates. Right? Okay. In the same way, this is going to be negative 1/2 and negative square root of 3 over 2 for this value over here. Okay. So you can see that you can easily generate the remainder of the values based on your knowledge of the first quadrant. Okay. Now I've filled out here for you all the corresponding y values. The only thing that will change, of course, will be the sign of the ordered pair. Okay, in the first quadrant, right, both of these will be positive. Okay, so both ordered pairs will be positive, like this. In the second quadrant, x will be negative, y will be positive. In the third quadrant, both will be negative. Right? In the fourth quadrant, x will be positive and y will be negative. Okay. Now, there's two things that we need to add to this. One is, of course, you have to understand that even these ordered pairs over here also correspond to sine and cosine. So the cosine of 0 degrees, if you were to even do this in your calculator, cosine of 0 degree would be 1, and a sine of 0 degrees would be 0. Okay, x is cosine, y is sine. And in the same way, cosine of 90 degrees will be 0, and sine of 90 degrees corresponding to over here would be 1. That's one thing that we need to add, okay? Now, the second thing I'd like to bring to your attention before I finish here is that angles can be measured forwards and backwards. So this is 30 degrees, and this angle over here is actually negative 30 degrees. So you can think of it that way as well. So, and this angle over here is negative 45 degrees going backwards, and this angle over here would be negative 60 degrees, okay? Negative 60 degrees corresponds to this angle over here, which is 300 degrees, right? You follow 300 minus negative 60. So angles can be measured counterclockwise, which is the standard method, or they can be measured clockwise, which would be negative degree angles, okay? And also remember, we have talked about this, and you can have 360 degree angle like this, and you can keep going. You can have another 360 degree and 360 degrees. So the angle can be, of course, bigger than 360 degrees, depending on how many times you go around the circle over here. So I'd like to summarize before I finish, inshallah, then. So this is a unit circle, and the unit circle is so named because the radius of the unit circle is 1. And the unit circle has 360 degrees, so we know this is 360 degrees, and half of it is 180 degrees, and this is 90 degrees, and this is 270 degrees. This is the knowledge that you must master backwards and forwards, so to speak. And the other angles of particular importance to us are the 30 degree angle, 45 degree angle, and the 60 degree angles, okay? And we have extrapolated from our knowledge from here, from 30, 60, 90 triangle, 45, 45, 90 triangle. We derived each ordered pair that corresponds to these angles. And then we noted that what's special about this ordered pair is that the x value is also the sine of this angle, and the y value is also the cosine. X value is the cosine of the angle, and y value is the sine of that angle. Thus, for any given angle, now let's extrapolate this knowledge, okay? For any given angle, let's create this angle over here like this, okay? Let's make it very distinct. Let's pick a color that we haven't yet picked a color. I don't know. What do you think? Let's pick something bright. Let's pick this. Hopefully that will stand out. For any angle like over here, let's call this angle over here theta, okay? We like to use theta a lot, okay? For any angle over here, there's a corresponding ordered pair, okay? And this ordered pair, xy, okay, corresponds to this, okay? The x coordinate, okay, will be cosine of theta, and the y coordinate will be sine of theta, okay? So this ordered pair right there, and that is the unit circle. So every ordered pair, therefore, okay, every ordered pair, therefore, the x value would be the cosine of that angle, and the y value will be the sine of that particular angle, sine of theta, theta being, of course, as you know, the Greek letter we've talked about. And that is the unit circle. One last thing that inshallah we'll add to this next time is radians, unit circle in radians. Until then, I request you to master this, and we really have to memorize in the first quadrant of the unit circle. Once you know that thoroughly, then you can extrapolate from this, and we'll build on this next time then. Until then, as-salatu wa-salamu ala rasulillah wa rabbil alameen. Assalamu alaikum.